Hi guys, welcome back to my channel. Today we're doing maximum ice cream bars. So it is a sweltering summer day and a boy wants to buy some ice cream bars. At the store there are n ice cream bars. We're given an array called costs of length n, where costs at I is the price of the ith ice cream bar in coins. The boy initially has coins to spend, and he wants to buy as many ice cream bars as possible. And they say, note, the boy can buy the ice cream bars in any order. They want us to return the maximum number of ice cream bars the boy can buy with number of coins. And we must solve the problem by counting sort. So in example 1, we're given this input array of costs of ice cream bars, and the boy has 7 coins, and we output 4 because the boy can buy ice cream bars at indices 0, 1, 2, and 4 for a total price of 7. So if we look at index 0, the cost is 1. So if we just add up all of the costs at these indices, then we'll get 1 plus 3, which is 4, and then plus at index 2, which is 2, is 6, and then plus at index 4, which is 1, is 7. So this is a total cost of 7, and that is all of his coins, so he can't buy any more. So then we would output 4 because he was able to buy 4 bars. In example 2, we are given costs as this input array, and the boy has 5 coins to spend, and we would output 0 because the boy cannot afford any of the ice cream bars, because these are all greater than 5, so he can't afford any of them. In example 3, we are given costs is this input array, and the boy has 20 coins to spend, and we would output 6 because the boy can buy all of the ice cream bars for a total price of 18, which is less than his total number of coins. So he can buy all of them, which are 6 total bars. So in this case, well, let's copy and paste the input. Okay, so let's also put the indices. There we go. Okay, so in this case, because we want to maximize the number of ice cream bars the boy can buy, and we're limited by how many coins he has to spend, right? And so to maximize the number of bars he can buy with the least amount of money, we want to buy as many cheap bars as we can, because the cheaper the bars, the more of them we can buy. Because if we buy 1 bar that costs 7 in this case, then that's all of his coins, and he only bought 1 bar, right? So, but if we buy 7 bars that each cost 1, then we can get 7, and that is a lot more. So we want more with less money. So in order to do that, we can sort the input array because we have the costs here. If we just sort it from cheapest to most expensive, then as we iterate through the array, we will encounter all of the cheapest ice cream bars first, and that way we can maximize the number of bars we can buy. So we'll keep track of the amount he's already spent so far as we iterate through, and the number of bars that he's bought as we iterate through as well. And then at the end, we'll return the number of bars he bought, since that is what they want us to output. So let's get started. So first we're going to start off by sorting the array. So we'll say arrays.sort costs. So once we sort it, then our array will look like 1, 1, 2, 3, 4. And let's move that so that they're aligned. Okay, and then once we have sorted, now we want to initialize our 2 variables to keep track of the number of ice cream bars that he has bought so far and the amount that he has spent so far. So we'll say spent will start at 0, and the number of bars will also start at 0. And then now we're going to want to loop through all of our costs and add up how many bars he can buy. So for each cost in costs, so we're only going to want to add the current bar that we're at if it doesn't exceed the number of coins he has. So if we start at index 0 and he has 7 coins, then we need to double check that the current amount that he has spent already plus the new amount that we're currently at does not exceed coins before we can actually buy that bar. So we'll say if spent plus cost is less than or equal to coins, because we only want to actually do it if, like, after buying it, it's not going to exceed the amount of money he has. Then we will add the cost to the amount that he has spent, and we'll increment the amount of bars that he's bought by 1. Because each of these costs is representing 1 bar. And then once we do this through the entire array, then we can just go ahead and return the amount of bars that he's bought. So let's run through this one time so we can see what's going on. So first, cost will start at 1 because it's a for each loop. And then, so he has spent 0. So let's keep track of this somewhere so we don't get confused. So spent is 0, bars is 0, and cost is 1, right? So cost is 1, he spent, so spent is 0 plus cost, which is 1, is going to be 1. 1 is less than or equal to coins, which is 7. So let's keep track of coins as well, just so everything's here. So 1 plus 0, or 0 plus 1 is less than or equal to 7, so we're good. So we'll add the cost, which is 1, to spent. So now spent is 1, and bars increments by 1. So bars will be 1. Okay, and then that is it. So then the next loop, the cost will be 1 again, because we're here. So then 1 plus 1 is still less than or equal to 7, so we go ahead. Spent plus equals cost, which will be 2 now. So he spent $2, or coins, sorry. And then bars will increment, so bars is 2. Okay, now next iteration, the cost will be 2. So cost is 2. 2 plus 2 is still less than or equal to 7, so we can go ahead. And then he has now spent 4. The bars will increment to 3. And then next iteration, then we're at 3. So spent is 4. So 4 plus 3, because the cost is currently 3, is 7, which is less than or equal to 7. So we can go ahead and add that to spent. So spent will be 7. Bars will increment, so bars is 4, and that is it. And then the next iteration, the cost is 4. And 7 plus 4 is 11, which is greater than 7. So that doesn't work. So we don't do anything in this if statement. Then we have reached the end of the array. So we exit this loop as well. And then we just go ahead and return bars, which is 4. And that is exactly what we have here. So let's go ahead and run this. Okay, so now our time complexity is going to be, so let's take a look at each section in the code here. So first we sort the array, which is going to be O of n log n, because that's just how sorting works. And then this is constant, so we don't care. This is looping through our costs array. So this is going to be O of n, because we are visiting every single element in this array exactly 1 time. So this is going to be O of n. And the inside of the loop is constant, because it's just an if statement, and then that's constant. So if we add these up, then O of n log n plus O of n is going to give us O of n log n, where n is the number of ice cream bars in our costs array, right? The total number of ice cream bars we have here is going to be n. Okay. Now our space complexity is, so we don't have any data structures going on here, but apparently technically in arrays.sort in Java, this is like language dependent, so it might be different depending on what language you use, but apparently for Java, arrays.sort actually has a space complexity of log n because of the call stack in the sorting algorithm, I believe. But go ahead and correct me if I'm wrong in the comments. But that is it for this problem. Thank you guys for watching, and like and subscribe if you found this helpful. I'll see you guys next time. Bye!